Hi, I'm Ruwen. Con was asking me to give a little talk on Javassist, and here I am. Just 2 words about me. Normally I'm a backpacker here in Australia, but I got somehow stuck in Melbourne. And since I got stuck in Melbourne, I started to work, and I work currently for Message Media, and at home I work for the Techniker Krankenkasse, which is a health insurance in Germany. But now let's go over to Javassist. First of all, why byte-code manipulation is better than reflections. First, it's much faster because it can be optimized by the hotspot compiler like any other instructions. If you use reflection, not so easy for the optimizer. And the second point is it's much more powerful. For example, you can replace every single instruction, and if a setter is called of an object, to mark your object internally as dirty, so the transaction monitor has to later commit it, you can do that, replace everything. This only works with byte-code manipulation. Javassist is not the only one out there. There's BCEL, pretty old, but still in usage by some other libraries. There's RSM and there's CGLib. The latest is, for example, used by Spring. Maybe some of you saw it in a stack trace so far when there's this in the class name enhanced by CGLib if you work with Spring. But the big advantage of Javassist is it has a really nice high-level API, so you actually don't really need any experience with bytecode. You can just work with your normal Java know-how, and you can manipulate things. Of course, you can also dig into the instructions if you want. This works as well, but it's mostly not needed.
And what's your involvement with Javassist?
I wrote my diploma thesis. I did an evaluation to move static code analysis tools from BCEL to Javassist. And yeah, and I played around a little bit more, and that's it.
All right.
And I have prepared two little demos. In the first one, I have an immutable tag interface. Probably some people of you saw it around, and I want to check if classes who implement that interface are really immutable. An annotation would, on the first spot, maybe sound better, but if you use generics, you cannot specify a list of classes which have the annotation immutable. So you need, for those kind of things, the tag interface. That's why it has to be, unfortunately, an interface. And an example usage could be looking like this. I implemented a simple name class which has a first name, a last name, and now it's better, an immutable list of strings with middle names. Just a dummy thing. And I will just show the list. I think the other things are pretty obvious. The list basically implements the list interface, and for all write operations, I throw an unsupported operation exception, and internally I keep an array list where I delegate all read calls to it. I use the generic types as well of list, and in order to only allow immutable types, I have a private constructor and some static factory methods. One gets, as you can see here, a collection of type T, and T extends immutables. This one you can put any self-written class which implements immutable. And there's another one, in this example strings, because strings doesn't implement my interface, so I have to have another one. And there will, if you do it properly, it will be more like integers, one of them, and all the classes you consider immutable, but you cannot modify. It's a little downside. But now let's go to the Javassist part. This class has a main method, and it takes as an argument a class path, just a directory with class files in it. And it creates for Javassist a so-called class pool, which contains objects for all the classes which are on the class path. And then I iterate, first, since, like I was mentioning earlier, not all classes implement my interface, and so I have to have a set with classes I consider immutable, because I need this later on for checking. I will show you. And here I go over all files in the class path, and filter out all class files, convert the name to a class name. It's a little bit nice Java 8 magic. And as you can see here, I have at the end the class name, and I get this so-called CD class object, and then I check if it's immutable with another method, and if it's immutable, or if it's supposed to be immutable, I check this. And to make error handling pretty easy, I just run a runtime exception every time something is not immutable. First implements immutable method is a good idea. I get here an array of the interfaces, convert it to a list because then it's easier to call contains, and then I get the class for immutable from the pool and see if it's in there, and then I can see if a class implements immutable. And the actual checking works. First I have a look if this class is considered immutable. If it's considered immutable, I don't have to check anything. Then I will check its superclass, because even my superclass maybe has also other fields which could be mutable, and I want to avoid that. And after I did this, I go over all declared fields. First I check if they are final, so I don't have to do the right checking all by myself. And final helps the optimizer anyway, so it's a good idea. And then I check if a field either implements immutable, or if the field type is considered immutable, or if the field type is a primitive. If none of those three conditions match, then I consider a field as mutable, and then I throw an exception. And it's a little demo. I go back to my first dummy class, and I will uncomment this one. And then I will run thing. I created a little Gradle project that just compiles the stuff and then calls the checker afterwards. That looks like this. The machine is a little bit slow and old, so it takes a little bit. And as you can see in the stack trace, it says class or final. And if I comment that again, it should pass.
So this also checks if you have a class that is a superclass for another class for another class too, that is
infinitive, yes. Yeah, this passes now. Any questions to this part? Because I also have a second demo on how to manipulate code.
Yeah, so quick question: is Immutable a standard Java interface, or is that?
No, I wrote it.
You made it up.
Yep. Yeah.
Okay. Nice.
That's why lots of Java types from the JDK doesn't implement it, and you have once take all the classes you consider immutable and should be used by your business logic or whatever. You have to once put them all in. This is a little bit boring, and you have to write wrappers for arrays and so on.
Yeah.
You have to do the work once, but afterwards it's quite nice.
Very nice. Yeah.
But so what's the advantage of what's the advantage of using that in comparison to reflection now? So you could do that with reflection, right?
Yeah, this one you could do with reflection, yes.
And what would be the advantage of using JavaAssist?
In this part, good. So far I went there. No one, but in the second part I will show you something.
So how did the JavaAssist come into play? I mean, I didn't understand that.
Okay, you compile the classes.
Yes.
And then it reads the compiled class files and operate on the bytecode. Or you can also hook it into the class loader and do it there.
Yeah. Okay.
But for analysis, hooking in the class loader doesn't make sense. But if you change classes, then it makes sense to have a reloadable class loader, so you don't have to compile and restart your application all the time.
Yeah.
At least for developing mode.
Mm-hmm. Yeah.
Okay, come to the second. Here I have a really simple application, which just creates a new customer, and that's all. And the customer class looks like this. Again, pretty straightforward. And I have a little entity annotation there I wrote myself. And I want, once the application runs perfectly and there's no exceptions flying, I want the content of this file to be written into a file called customer. So kind of an auto commit, except if the transaction is raised, then it should be a rollback performed. The application server looks like this. It just creates one transaction, registers this transaction as a current transaction, runs here the application, commits it, and if an exception flies, it rolls it back and prints back trace.
And this application is an interface, or is this a...
Yeah, this is an interface. I can show you the just as a run message, just something pretty simple.
Okay, yeah, okay. But that's your...
It's all mine.
Yeah, okay.
Now the transaction, which can only write but not read at the moment. In the static field current, I keep the current transaction. If you want to use multi-threading, you have to do a little bit more work. And I have a hashtag where I collect all the entities I want to save. And I have here an interface called iEntity. And every class which has an annotation entity should later on implement this interface iEntity. And when I commit, I go over all savables, write into file, and that's all. Could be if in a real-world application, database, and whatever. But I just want to keep this sample easy. And this is the interface. This is the name of the file. So this would, for the customer, always be customer, and this would be data, which is to say. And now I will use Javassist to implement that. Again, I have a class pool and I go over all classes, pretty similar like before. And here if I check if a class has the annotation entity, then I first add an implementation for the get methods, then for the get string to save, then I add the interface, then I extend the constructor in order to register any new instances as a transaction, and then I write the modified file to disk. The get name method is pretty easy. It's just this. I can just write as a string the Java code. This will get compiled into bytecode and then will look like any other method. Similar with the get string to save, even though I use here a string builder, iterate over all declared fields, and kind of write Java code which would execute like field name equals and the value of field name. And here I add this method I newly created to the class. And then the part, could be still probably done with reflection, but the part which kind of is harder is here I go over each constructor, leave it as it is, but would just add a little bit extra code, and you would also be able to change the existing code. And the only thing I add is call the current transaction and add this object which is newly created to the transaction.
So how does Javassist do how does Javassist do this compilation? Does it embed Javassist?
No, it compiles the bytecode and changes the file. It has an internal compiler.
But for the string Java source you've got there, that's not bytecode, right? Does it parse
No,
itself?
Yeah, I don't know actually how it does it, but I think it has a compiler. Maybe it's an interface to the existing compiler in a JVM, or it has an own compiler. I don't know that part. But it calls this one and then writes the newly created class back into the bytecode, and any other class loader then cannot make the difference between you doing it and someone else and the normal Java compiler doing it. And if I now run the whole thing, I would expect in a file in my temp directory to have this contents written. There is the output of the string buffer. And to show that I don't cheat, any wishes?
Not JVM.
Okay. And to show the rollback, I will just uncomment this little exception here. And nothing in there. This is just the writing part, which is a little bit easier, but if you want to also have the reading part from something, you would create something like a find annotation, and with parameters, for example, find and then key, and then you would replace the code by querying a database and whatever and returning the object. Any questions to this one?
Where does the modified class get written to? So you showed
To the same folder. At the moment, I write it to the same folder where the compiler put it in.
So after execution, you'll just be sitting there as well?
Yeah, it still sits there. That's why you, for developing, probably want to have your own class loader, which just does it all the time on the fly, so you can get faster changes.
If you do it on the larger scale, you get interesting problems. For instance, if you have stack traces and then you suddenly have references to methods you haven't written.
Yes.
Is this becoming a problem? I mean, that's a discussion. The AOP community. AOP is based on this, right? Aspect-oriented programming.
Yeah.
Aspect J, for instance.
I never worked with this,
exactly
but
this on a slightly higher level of abstraction. Yeah.
Yeah, I know those problems.
Yeah.
In my company at home, we do this exactly for everything.
Right.
It's sometimes a little bit annoying, I agree.
So do you have any kind of practical advice how to circumvent this, or?
You can also manipulate line numbers in stack trace and so on, so people have it a little bit easier.
Right.
Because so if you code, line numbers get lost, but you can add all the information afterwards. And try not to change so many code, but try to make it more transparent. So don't change existing code, but wrap something around it. It's probably an advice, but otherwise, stack trace will stay ugly. Mostly people will just focus if the package prefix is theirs, they have a look, and if it's a weird package prefix, which is then framework classes, ignore it.
Does Aspect J somehow, Aspect J, Javassist marks those artifacts and grades as synthetic or something?
I'm not sure if it does mark them as synthetic. You can mark them as synthetic.
Yeah.
But I'm not sure what he does with the Java code I just write there. But if you create a new field, you can mark it as synthetic. Next part of my first slide. Any other questions?
What about performance? Because when Java 8 was released, developers of Java told that reflection now is faster than CGL if you provide the full access to class, yeah? So, do you know something about this?
No, I don't have any performance numbers, especially not on Java 8. I know that traditionally it's faster, because it behaves like a normal code. So optimizing and everything can take place. I know that reflection got over the years much faster than it used to be, but I have no idea where it currently is. And as you already mentioned, there are some pitfalls, and there are even more. First of all, the generated code will be seen as real code for any other application. So if you do static code analysis on your enhanced code, you see probably weird messages because the developer wrote something and suddenly you will get warnings or bugs on code he never wrote. So if you do static code analysis, do it before you enhance the classes. Then the synthetic fields can be really a problem if you do any analysis and, for example, the compiler generates synthetic fields and you suddenly start to look at fields and error messages and you don't find this field in your source code. So mostly if you do any checks, check for synthetic fields, just ignore them. And about the code analysis as well, some things cannot be done with byte-code analysis. If you have a try catch statement like this, and you want to check that the catch block is at least commented, if it's empty, impossible with byte-code analysis. So tools like BMD, which do checking on source code level, are still recommended. Anyone, any questions?
So what would a good use case be for Javassist, like as opposed to ASCII programming, for example?
I would say you have more control. You can really change things the way you want to be. Aspect-oriented programming does it on a higher level. But if you maybe you have some requirements that doesn't match with AspectJ, and then you can still do it with JavaAssist. And at home where we started, when we were starting, there were no such things like AspectJ and so on. That's why we didn't re-evaluate recently. We only moved from BCEL to JavaAssist. And so far, quite happy.
So what do you use it for? Just
we have something like a hibernate replacement, because we don't commit to a database. We go first on, we have some legacy systems, and they have to be included in our transaction. So we go to the mainframe, execute all SQL statements there, execute COBOL programs, and commit then. And to have this kind of nice things we use it for. Our whole application server is based on that, so we just annotate classes and then they work as queue consumer and queue publisher and so on, just to make everyday programming much more easier. So you have to write less boilerplate system close code.
How do you debug that?
It's hard. Sometimes it helps if you just write out the bytecode to get a decompiler and then have a look what is actually generated. It's not as easy as debugging normal code, I admit.
But so you're saying that you patched an application server, or you built it in own
We
application?
did all our own.
Instead of using Tomcat or
Was on. We started in 1998, and so there was nothing like Tomcat and so on.
Okay. And is that still a good idea?
So far, we are performance-wise and so on quite happy with things.
Can it do it at, making it even more obscure, but can it do it at class load time as opposed to on class files on disk?
Yeah, you can write your own class loader and hook it in between, and then you read the class which will be read from disk. You just read the byte array, load this byte array into JavaAssist, and you do whatever you want to do, and pass the generated class out of it to the class loader.
So, if you ever look at the daily WTF website, I can just see sort of never get fired because I'll never be able to figure out what your code did ever again if it's sort of rewriting its own classes on the fly.
Well, isn't that the problem with AOP as well? That, you know, if you don't, well, sure, if you know the project, then you know that you also have to look in the AOP stuff in order to figure out, you know, where, you know, some stack trace came from. But
the more magic you have, or like framework magic you have in general, the harder it gets to debugging. If things working, they are nice, but it's not as easy to debug those applications as normal ones. Especially if your Eclipse debugger debugs into lines which doesn't exist, and so on, you will have this at some point. If it's set up nicely, you can also then debug into it. Mostly you want to write classes and then just link them together with what the normal application developer did. So there's not so much generated code, and then you can debug to the framework classes as well.
I know at least two good examples, if I can jump in, because this stuff is actually used in production. And I'm not quite sure they use exactly this on ASM. The one is test coverage tools, Emma or Clover. Say instrument bytecode to create those labels which they then take off if you run the code. And then you never really debug this kind of stuff, so that works pretty well. And the second example I know, does somebody know MBEL? MBEL is a template engine or an expression evaluation engine. And that is where speed really matters. So if you have expressions like numeric expressions, defined variables and this kind of stuff, you can interpret this, but then you get this interpretation overhead. What MBEL does, it compiles it on the fly into bytecode. And I think JBoss rules uses it underneath as well.
And yeah, it's under JBoss for the whole project now, right? It started somewhere off in Japan.
Yeah, it's a Japanese professor who came up with the same.
Yeah, but now JBoss in the application server, they also use it somewhere. I don't know exactly where.
It might be the rule engine, and it might be MBEL. That's how I got into this. Yeah.
well, yeah, then I could see the usability for if you're a framework designer.
Yeah,
but as an application developer.
No, as a normal small application, I wouldn't probably say so. Yeah. But it's nice to play around, so you know if you use Spring what you get.
Yeah, that's true.
it's not for a really normal, really standard application. It's something, if you write a big framework and you have a lot of classes which are using this framework, because it's some effort in the beginning, but to get paid back, you need some users. If you just write it for 2 other classes which use it, I wouldn't do that.
Yeah.